Hello, I'm Denis Bubnov from InnoStage. I specialize in development of the projects related to the network infrastructure, data protection solutions for various companies. And my experience spans for more than 10 years. And as one of my hobbies, I also work as a teacher and a certified Cisco Microsoft trainer. Today, I would like to discuss and show to all of you a very interesting project, which together with the team, we did together, like I said, and we keep on improving it for our respective customer, one of the large banks, and I would like to show some interesting examples to you and show what we have actually done and what we have achieved. So right now I'm going to open my slides. So this is the creation of the safe data center network. So that's what we would like to start. In the beginning, we would have to describe the customer or the customer's goals and requirements and the prerequisites for having this safe and automated data center. And we describe the digital transformation steps, describe of how the customer's business is changing at the time. And we'll describe the network, the physical and the logical structure of the data center, and the business requirements needed and how they were implemented with the use of this technology. Take a look at the results and analyze the innovations. And later I'll take some of your questions. It's a big bank, speaking in terms of a customer, it's a big bank which currently is going through some digital transformation. Seems like that we can all see that quite a lot of banks that are trying to move along on the edge of time are becoming IT companies, and that's their digital transformation that we're talking about. The more and more their business is moving towards the IT aspect, and they keep on minimizing on their traditional forms. So the more and more applications they start having, the more digital tools, and this customer of ours is not an exception. They've also decided to move along with time, and these are the requirements this bank started having. This bank has quite a number of developers, and their number is growing together with the digital transformation. And these developers are launching more and more products to the market, and more new banking services are launched into the market to allow the bank earn more money. And one of the business requirements of the customers to the project, to the actual data center infrastructure, was having the launch of the new software solutions in a very short span of time. So the configuration should be automated and very quickly adjustable, so that the developers can very rapidly get their resources, their virtual machines, their containers, and they would be addressing their testing and other needs in a very quick and efficient way. Also, they would have to minimize the operational costs. The infrastructure is becoming bigger and bigger, and the staff members, the number of staff members started growing. And the customer wanted to avoid all that. They wanted to avoid having the growing DevOps And they wanted to pursue one next goal, to cut down the operational costs. And they wanted to minimize the downtime. This bank was actually virtually turned into an IT company, moving to the internet market. So the importance of the infrastructure was becoming more and more important, and the downtime, which was related to everything which was related to downtime and malfunctions of the equipment, everything which was related to some other issues like engineering issues and power issues had to be minimized, because the non-operational service for the customer resulted in direct losses. One of the requirements was the utilization of the resources by business partners, because this bank had quite a number of partners with the very sophisticated and very branched infrastructure. As this infrastructure started growing, it became apparent that some of the branches were utilizing more resources and some of the branches were utilizing less resources. And the question was how to measure all that. The question was how to make sure that it becomes obvious whose initiative was all that, and who consumes more resources, and why would have to buy new servers, so why would have to expand the data center. That was one of the reasons to launch the project. And since the bank was the IT company, they wanted to be scalable. They wanted to become scalable and do it at a fast rate, and to implement and deploy new capacities on time. And this bank had quite a number of projects which were related to the social sphere, to the social area, that would guarantee the normal existence of good citizens. And those services would have to be running 24/7, and the unplanned downtime should be minimized for such important services. All those requirements were turned into technical requirements. Reliable and scalable data center architecture, because they had the current data center, which was rendered to be obsolete and had been built by utilizing a very old architecture, utilizing old and traditional technologies. And they wanted to use the principle of isolation of their business departments and branches and partners. They wanted to have proper orchestration and integration with the virtualization systems and maximum automation of the routine tasks. It was one of the key requirements. After multiple set of rounds, after multiple set of discussions and simulations, we had selected the network solution, Cisco application, Cisco Aci, which had addressed all of these needs. Cisco Aci is a new, not quite new, I would say, but established solution, which we have become experienced in implementation, and it's a established effective infrastructure which identifies a number of abstractions, which is software defined, and it has very good integration with the remaining IT infrastructure, like for instance with virtualization and orchestration and other things. It maximizes the safety requirements. It supports multi-tenancy. When this network solution can support a work of a number of independent items, tenants, independent tenants. And these tenants can handle their part of the infrastructure without actually affecting any other ones, any others. Also, macro and micro segmentation were applied with different security appliance. The physical ACI structure is here. First of all, it's the data center architecture, close architecture, spine leaf, as we can see on the slide. Spine leaf, which is based upon spine switches and leaf switches to which server infrastructure gets connected. The data plane utilizes VXLAN technology, which is a contemporary stack which provides a high performance, good load balance, and it excludes the inherited solutions like spamming, for instance, spanning, and meets the customer's needs in a better way. ACI is based upon Cisco Nexus 9000 switches. It can be built upon only these kinds of devices, and it can be managed only with the specialized controllers, physical controllers entitled EPIC controllers, the management systems that do manage this whole infrastructure. And here we are moving away from the handling of the individual handling of the devices to the abstract handling of the entire fabric. And the EPIC controllers help us integrate with a whole lot of other infrastructure solutions which are integrated with the safety solutions. And apart from that, for making sure that the system is contemporary, we use state-of-the-art switches from 1 to 400 gigabit ports, I/O ports, having the appropriate throughput capacity for the tasks required. This is sitting in a data center building they had rented. That was the decision made by the customer, and some of the elements of that infrastructure were deployed in their headquarters. ACI provides the scalability options of a different level. For example, we can speak about the deployment of the private cloud. ACI can help us run a private cloud in our data center, and we can connect a few data centers and manage them with the use of the uniform system. And these data centers can be located elsewhere in different places, connected by good throughput channels, not only the optic, but also internet, MPLS, whatever, because we know that there is some requirement for latency, but it also stipulates the hybrid cloud. ACI stipulates the hybrid cloud capabilities where we can integrate this private cloud, and we can put the EPIC controllers and handle some Microsoft Azure services and Amazon, for example, Amazon Web Services. And by doing that, we can expand our service to private clouds and make sure that we run a very reliable, flexible infrastructure with flexible addition of the resources when necessary. So you can use the private cloud, not only on-prem, but also in the public cloud, in the public data center. The logical structure of ACI provides some abstractions. For example, on the left-hand side, we can see some number of very complicated technologies that can be identified by only networking experts. Networking experts are required to tackle those, and very often it's very difficult to make them use for other purposes because they speak VLAN language, as we put it. They speak about routing, they speak about VLANs, but ACI helps us get abstracted from that, and we end up having a new logical stack when tuning this whole. And this logical set is very simple to understand and looks very much like what we have when we run this service in a public cloud like Microsoft Azure. And here's we have the tenant. We have the tenant, the one whose infrastructure this is, a logical part of the data center where we launch this infrastructure. Here, in terms of this particular solution, production, pre-production, test environment are related to the tenants. They are fully isolated. Whatever it's done in a separate tenant, all other tenants cannot influence that. And the mistakes in one tenant that can occur in the test mode, in the developer mode, cannot affect the production performance of the system, so that the customer would not have to deploy their own infrastructure for tenants. They could have done it just the way it was available, not taking care about availability. There can be multiple tenants there. There can be 2, 3, 8 of them. Any number of them. The bridge domain, BD, is the abstraction which explains the interface of the virtual switch. Subnets, as you can see, subnets are of the few items and this interface. So in other words, they are just virtual switches. And inside the bridge domains and subnet, we have point proof with hosts, with virtual machines. And the interaction between these applied things are called contracts. And we'll speak about contracts in the following part of my presentation. The difference between the things that we have got used to, for example, it runs through a controller, through a graphical user interface, and this model is not related to the devices, is not linked to the devices. That's important to address. It doesn't really matter where this server is connected to. This server can be connected to the leaf. It could be located in the data center. Still, this logic applies. The tenant logic, the virtual switches and routers is done in the network, regardless of their physical location. It's one of the advantages of the ACI, which allows us to very drastically cut down the operational costs by using the new abstraction model, having all of these gray boxes in this slide, VLANs, MACs, tuned automatically and not requiring any specific effort by the administrator. Everything is done on their own, and it's done by the controller, APIC controller. The ACI ecosystem is not isolated. It has a number of integrations with different solutions in virtualization, public clouds, automation, safety, etc., etc. All these things that are shown in the slide, as you can see here, of well-known vendors, they have their own products, they have their own solutions, they are integrated in ACI, and they allow to work with them, not with the external entities, but to work with them independently. But the customer was more interested about safety and security options. Security options like firewalls and the NGFV with some intellectual modules added, and virtualization solutions, automation solutions. All those capabilities belong to ACI. It's capable of integrating all of them as well, making sure that these functions are related to that system. It's an interesting thing for the customer. Yet another thing which is different from ACI, it's the contract mechanism. The contract mechanism which allows us to make the following things. First of all, there is a filtration. We just connect some servers and virtual machines, some other services, and they start seeing each other immediately. They start working, start interacting with one another. That's, on the one hand, it's very good in terms of the simplicity of settings, but it's very bad for security, because very often you would see the customer having the infrastructure in place when the developers and system administrators are interested in having everything on one VLAN. Everything sees each other, no efforts. Everything is done very simply, and everything is targeted at the segmentation of the network with ultimate control, which would help them make this service quite safe. But here, the contract mechanism is about all of these dreams of the security experts. It makes separate sets of services, regardless where they belong in the network. They interact only by using the certain safety and security policies. Some of the ACI functions are making sure that for interacting with one another, these have to stipulate the safety and security mechanisms and this native deny mechanism. When we create some switches and virtual machines and some switches, something else, or like some hardware components have been added, there may be different options, and they cannot interact with one another, even if they belong to the same VLAN, even if they belong to the same network. They cannot interact before we provide certain security policies. And these security policies, when the entire traffic is allowed to work with, they can be done in a very proper way. Like, for example, like this diagram depicts here on the slide, EPG, a classic three-way structure. EPG front, having different virtual machines, and BM server, which interacts with the applications on the virtual machines, and EPG applications interact with the endpoint database with some ports. Thus, without any specialized appliances, this network fabric is turning into a very distributed firewall. This firewall is capable of filtering up to level 4 with the use of the TCP and UDP ports. It provides filtering capabilities for all of the applications. It creates yet another non-apparent advantage. When we have such a fabric, we have to create virtual machines taking into account the owners of the services. So to make sure that this service runs effectively in this fabric, we just need to read through the documentation, describe all of these dependencies, and run it. So all of the interactions are in one VLAN, and then we don't really know what to do with that afterwards, what to do with these services afterwards, how to protect them in the network. But when we use ACI, this function is done by design. It's very simple. The filtration also in L4 is done at a linear speed, and it does not use up all of the resources like hardware switches. Going back to the previous ideas of mine, we know that there is a migration. The virtual machine would migrate to another host, to another data center, or it had been moved elsewhere to the public cloud, to another data center. And the contracts do remain there. The contracts do remain, and the model did not change much, and it's done automatically without the involvement of the system administrator, and it does not require any involvement of them to add these functions. ACI also supports micro-segmentation, so we can filter the traffic between the endpoint groups, between the virtual machines and servers, and that are a part of one application. But apart from that, we can also do the filtering inside the endpoint groups, like it's shown on this particular slide. All these virtual machines are running inside one network. It's 10, 20, 30.0. They run like that. But even without the micro-segmentation between them, any interaction is allowed between them. Just like with the normal network, in the normal network, but with the use of the micro-segmentation, however, we can create the policies, access policies for virtual applications and inside the endpoint group. It also works, and the filtration is also done by the contract mechanism, which I mentioned previously, which is supported by access control, and it provides the same functions between level 2 and 4, and it doesn't really matter whether it's a virtual machine, whether it's a bare metal, or that's the virtual machine, machines running in different hypervisors, like VMware, for instance. It is all done on a linear speed, and it does not affect the performance of the fabric, and it does not affect the performance of another network. But yes, that there is a subtlety on how it's done. in virtualization, for instance, we have a few virtual machines, and in between them, microsegmentation is established. So we have these virtual machines and we interact with them. It's done inside the VLAN. It's inside the distributed switch, the VMware. In actual fact, it's done inside the server without physically leaving the boundaries of the network. But if we are talking about ACI, if we are connecting it to the fabric, the virtualization solution can be using private VLAN, PVLAN, which would allow us to create other secondary VLANs, which would isolate virtual machines from one another, and their interaction can only be run with the special ports, with specialized settings. This private VLAN technology, for those engineers who created and used that, is kind of difficult in usage, because apart from the normal logic of VLANs, it adds yet another secondary VLAN, which is not a very popular approach for microsegmentation, because it is scaled in a difficult way. But in terms of ACI, everything is done automatically and without actually getting into VMware settings. The administrators do not tackle that, but the fabric and the ACI controller is capable of programming the private VLANs by using the VLAN pool that this ACI controller is handling, so they can do this micro segmentation in a virtual switch, VMware virtual switch, and virtual switches belonging to different vendors, thus supporting micro-segmentation. In other words, 3 VLANs can make us sure that we comply with the requirements and we meet the needs of the contract, despite the fact that these virtual machines are not directly connected to the ACI infrastructure, but with the use of the PVLAN, we can successfully run it, which we did, and the customer is not having yet another headache on how to tune it all. It's all done automatically, and this whole infrastructure, the fabric and the virtual switches, is all managed from the fabric. And we'd also have to make sure that we install the components, the virtualization solutions, and have a more deep integration capability with the fabric, and have complete adjustments, broad adjustments with the use of the controller. And the integration, which would help us manage private VLANs, were sufficient for this particular customer to take the interaction with these systems under control. Also, we provide integration with the security solutions. One of the customers had selected a number of systems, checkpoint systems, which had supplied a few services of firewall protection with the L2 transparent routed firewall modes, and they had integrated that all into the fabric. And they are not only just connected as devices there. This fabric knows that this is a firewall solution. It's some kind of a external L2, L4 service, and is capable of routing the traffic to them, with the use of the abstractions which I mentioned. The fabric knows that that's a firewall. And detects some of the interactions that can be led through the firewall, and some of them cannot be led through the firewall. And MGFV is used here as the deep security analysis tool. So the primary traffic filtration, including the level 4 TCP/UDP analysis, is done by the fabric. But the deep analysis of the packets, intrusion prevention, everything which requires high intelligence, is supported by NGFV. And we let only the filtered traffic in, which does not contain any alien and not approved elements. And knowing that NGFV is not the fastest and not the cheapest solution in the market, still we know that the fabric takes away some of the load of NGFV and provides good integration. A very important part of the project was orchestration and automation. Like I said, for the developers, it was very important to constantly create new essences, new virtual machines, doing the tests for them, making sure that they run properly, interact in a proper way. So this automation, working with virtual machines, virtual environment, it requires a very sophisticated approach in terms of life cycle management of the machine, starting from the deployment of the virtual machine. These are the VRF, BD, EPG contracts. We've managed to use the VMware automation solution, vRealize automation, for orchestration and automation. With the use of that, we know that virtual machines are created with the contract of the self-service, and automatically a new set of VRFs, bridge domains, EPGs, and contracts is created automatically without actually using the registrator, because previously we needed to acquire just a few specialists, a few networking experts and other experts which would create the necessary VLANs, would be adding trunks and access control lists for internet access. Firewall rules were applied by them manually. But now, with the use of the automation, with the use of the ACI infrastructure, such things have been completely automated, and basically for the customer, for the developer of these services, the full automation of the entire life cycle of the virtual machines has been established from the actual inception date to the elimination vRealize manages the resources, the pools of IP addresses, VLAN pools, and it provides a very harmonious interaction of virtual machines, the network, and the complete automation without actually using a large number of experts, DevOps. Reporting is also very important here. Reporting is generated for the customers' managers, where they can see this in a full and complete transparent way. They see how many essences have been created. They see how many gigabytes have been spent in the storage and how CPUs there were and how many virtual machines have been created by this and that business unit and by this and that partner. So the customer immediately knows and sees what they can do for their partners to provide the partners with the appropriate resources to make sure that their partner would have their own admins and policies. But by using this tenant mechanism, these partners would get all the necessary functions and would be capable of running their services without interrupting the bank's operations on the whole, and they wouldn't need to have to establish their own infrastructure. They would be running just one single production infrastructure and the support infrastructure, etc., etc. They would be using the uniform infrastructure by ACI. For the customer, there would always be a prospect for fast scalability and the development. They can scale up and increase the capacity and performance very quickly so that the customer can develop both on-premise, so they can arrange yet another data center, put in the Cisco ACI solutions there, putting it together as one system which would comply with the policies, and this logic would automatically be migrated to yet another data center that the customer can use for disaster recovery and scaling up their business for whatever reason. Building their own data center is not always a fast solution. Even if there is a premise, if there is some engineering infrastructure, you still need to buy some equipment and connect to the data transmission channels. And when the business needs to develop very rapidly, this is when the customer can consider a public cloud solution, which would completely keep the infrastructure with the virtual controllers, having the same logic as they have in their own data center. It will be replicated on some kind of Amazon Web Service or Microsoft Azure or some other public cloud solution integrated with ACI. And a number of partners in this ecosystem is growing, is constantly growing. They would always be getting new partners in security solutions and virtualization and automation, etc. More and more partners spring up every year. So the capabilities of this network do support it. Yet another important and interesting solution we have here to control the data center activities, which we consider with the customer, is Cisco Titration. It's the embedded solution into ACI, which allows us to run, have the visibility of the processes in the data center using the virtualization approach to the virtual machines, etc. The nano segmentation, as we call it, when we have the macro segmentation with the contract mechanism and micro segmentation, it can be we can fine tune it with the IP3 solutions. If the Windows firewall is used, for example, it can be supported with Cisco Titration. Titration has the traffic visibility in the data center, the visibility of each process, doing mapping of all these processes. It's very, very efficient when each customer has its own past. They have inherited quite a number of legacy services which have never been documented, and they don't really know which traffic runs in between them. It costs quite a lot of effort and resources to identify them all in the production system, which is a very complicated task. And these systems sometimes interact in between one another. And very often the customers need to understand how it all works. So together with the titration, they can have this visibility and show how these devices interact via the fabric and the virtual environment. What are the results? What did we get? All of the business requirements which the customer had stipulated had been reached with a very, very good performance. And we minimized the launch of the new software products. We reduced time to market. The services were fully automated when launching. When a certain service was ordered, a set of virtual machines, for example, all of these settings were done with the ACI and vRealize, which I mentioned, which reduces the waiting time for the customer. It is reducing it quite significantly. The productivity of labor of the customer has increased, and the development time and time to market were reduced so that they could launch their products much more quickly into the market, because they reduced the costs quite significantly through that automation. They reduced the operational costs on IT because they wouldn't have to hire new IT experts through automation, and because of the routine tasks were not put on the admin's shoulders, they managed to avoid hiring more and more additional staff members. System admins, system engineers are not required in big quantities. They reduced the unplanned downtimes, of course, because ACI is a system with high provisioning, because all of the downtime issues had been backed up and provisioned properly. So it really helped reduce the unplanned downtime quite significantly. Therefore, the customer reached that goal. And the control over the IT resources used up by the partners and business branches was established. That became much more transparent for the customer. Fast business scalability was established by increasing the on-prem compatibilities and public cloud. All of the technical requirements had been implemented. On how they have been implemented, I've explained that. The isolation was provided through the tenant ACI. The manageability orchestration was done with the ACI and vRealize. Therefore, we were able to achieve very good results and build a data center network for that customer, which was not software defined, but it was having very high automation level, and it had a new stack of technologies and abstractions which allows the customer to manage the system in a different way, and it provided a due level of security for the new services and for the legacy services which were imported there by segmentation, micro-segmentation, and integration of all those legacy services with the contemporary security tools provided by ACI. I'm done. Thank you very much. And ladies and gentlemen, I'm ready for your questions, if any. Thank you. I would like to thank you for your time. Thanks for joining us. For some technical issues and for some technical clarifications regarding the experience of our company, regarding the solutions